Okay, hello. We've come a long way, haven't we, in the past 20 years, since the 90s. I mean, back then, you would have some friends over, it'd be going great, but then two of your friends would start having a disagreement involving the release date of Ghostbusters. But then it starts to get heated. None of them are backing down. The mood of the dinner party is at stake. But it's okay, for you hold aloft the answer. For you are the proud owner of Microsoft Cinemania, giving you instant access to the history of cinema. Well, it's not really instant, though, is it? Because first you must go to the room with the computer in and turn it on. And then, clunk, all the fans start whirring. You get that friendly, static crackle as the CRT monitor whirs into action. Windows 3.1 slowly boots up. And then you get your desktop, eventually. And it does this. And that really sets expectations. We are dealing with an operating system that thinks booting successfully is a fanfare-worthy moment. And by the power of multimedia CD-ROM, you reveal authoritatively that Ghostbusters came out in 1984. And you did that in under 10 minutes. The dinner party is saved. The web really changed everything. With the web, you get the information instantly, no installation necessary. Native apps such as Cinemania and Encarta, they looked out of date almost instantly. Having separate apps for these things just became weird. The stuff on the internet was better. It was built with this new, interconnected, modern world in mind. The browser runtime started to replace more native apps, email clients, office tooling, video players, code editors. Native apps became the exception. If you look at the top 10 selling laptops on Amazon, they include Chromebooks. That's how secondary native apps are. Although that's not true on mobile. Their native apps still rule, because they build to the strengths of the platform, and a lot of the web predates that. Some of the web is hostile to mobile. This is a creative agency that I won't name, and this is what you get if you visit their site on a phone. It says, choosing your creative agency isn't like buying a pair of shoes. So why don't you make yourself comfy and visit our site on a real screen? But they're kind of right. Choosing a creative agency is not like buying a pair of shoes, because I have never had a shoe tell me to fuck off and come back when I have real feet. If you go to their desktop site, it's a lot better. You can see the stuff they've done and the things they're expert in, which includes responsive sites, of course. The more worrying case are sites that are simply hostile to just the mobile web, not the whole mobile platform. This is a horrible situation. The user has gone to these sites in a browser, potentially following a deep link, and rather than sending them the thing they want, we send them to another place where they can download a thing and install that thing, which they can run, which may contain the thing they originally wanted somewhere in the interface. I don't think anyone's saying that's a good user experience, but it's one that many developers think is worth it to get users off the web and into a native app. And why is that? Well, think about the native apps you use, the ones you rely on. That is where the web is failing. What caused that failure? What features do they have that you use that make them impossible to replicate on the web? For me, I use these apps often, or I rely on them in some way. And they can't be done on the web because of push notifications. This is vital for the apps in yellow. They tell me someone sent me something, or something happened in the background when the app isn't open. I rarely use TripIt. I rarely open it. I forget I have it. But then it'll send me a notification saying a flight is delayed or cancelled, and that's really valuable. Background sync, send and receive stuff when the app isn't open, from downloading podcasts to sending an email later that failed to send at the time, which takes us to offline. I depend on this for more apps than I realize, from playing music, checking where my hotel is, looking up a meeting location. I don't want to depend on connectivity for these things. And of course, we need better performance and better integration into the operating system, battery stats, payment, and account integration. Everything that makes it first class on the platform. The web can't do these, and that's a bug. But what gives me hope is that these are bugs that are getting fixed, like not just being thought about. Code is landing to fix these things. And these are the ones I want to talk about today, because these require something new. Background sync, that happens in the background. Push notifications are received and dealt with in the background. Offline, it doesn't run in the background, but it requires another context to run before pages. And that thing is the ServiceWorker, and this is the spec. That bit got a round of applause at Google I/O. That's... Don't patronize me. I could have dressed it up a bit, of course. I really like what graphics cards do in this respect because, graphics cards are just circuit boards, but they need to sort of dress themselves up to try and make them look like the must-have for people, even though they really don't do anything on their own. The boxes they come in are amazing, this kind of sub-deviant art crap. You get the usual sort of sexist nonsense that you get with gaming, but you always get things like the hideous offspring of Shrek and Yoda. I love that. And also Teenage Mutant Ninja Dog. So in that vein, I present to you the ServiceWorker. That's Mumra, the ever-living, using his evil powers to control browser features. We need a logo really badly. Stop me before I design again. This is a feature being worked on between Google, Mozilla, Samsung, and other third parties. It's like a shared worker in that it's shared between many pages and has no DOM access, but unlike a shared worker, it can exist without a reference to it, and it's shut down when it isn't in use. But this is the background JavaScript context we need. It's in browsers today. If you want to use it today, you'll need Chrome Canary or Firefox Nightly. In Chrome Canary, you'll need to go to About Flags and enable experimental web platform features and give the browser a restart. If Chrome isn't your thing, then you can use Firefox Nightly. Just you need to go to About Config, and in there, enable dom.serviceworkers.enabled, and give the browser a restart. I'm going to stick with Canary for the demos. Google paid for my flight and hotel here, so it would be rude not to. But also, the debugging tools are further ahead. But I'm told Firefox is catching up there soon. If you want to know what's supported, all of the sub-features, it's ServiceWorker ready. It breaks it down and tells you which browsers support what. So first, let's take a look at offline, because it's the foundation for the others. Offline suffers from the same misconceptions as progressive enhancement, I think. Like, people say, my app doesn't need to work offline because my users have permanent internet connectivity. But it's not just about zero connectivity. It's about treating the network as an enhancement, one that might not be there. When the user clicks a link to your site, they enter a URL, this starts a navigation, a document is created, but we have to go off to the network to get the data for that, and that can take a long time. It will come back eventually. We can't render at this point. We need to send off the requests for the sub-resources, the CSS, the JavaScript, the images. As these come back, we can start to render, but those sub-resources trigger other sub-resources, things like XHR, fonts, images used in the CSS. When they come back, we get towards our final render. As a practical example of this, I'm going to take Train to Frill, which is a little demo site. It's a responsive site. It displays the latest train photos from Flickr. Don't ask me why trains. I was on a train when I started building it. I had a moment of zero inspiration. But let's load it on a phone with an edge connection. So that's 250 kilobits. 15-year-old me would have killed you for a 256 kilobit connection. It's not the best today, but it is far from the worst. So 3, 2, 1, go. We get to first render. That wasn't JavaScript dependent. We get content after about 5 seconds. That's from Flickr. No images yet, though. Those images are about 200K each. That's what Flickr gave me if I wanted enough pixels to cover a device of this density, a 1080p screen. We get the first image through after 30 seconds. Other images start loading, and eventually, after what seems like years, we get the full render. Now, that video wasn't real time. I had to cut it down. It took so long. Those are the correct figures. Of course, we could compress those images a little bit better. We could do things to ensure that the top images load first. I just took what Flickr gave me. But we are still beating native at this point. The equivalent for native is the trip to the App Store, the download, the install. It's a slow and comparatively poor user experience. But native kicks our arse on the second visit, because it used that initial download to install and cache loads of stuff. We have the browser cache, yes, but the whole internet is fighting for that. And if we change one line in our CSS or JavaScript, we have to change the file name, we break the cache. And we like to deploy often, so we're breaking that cache often. But this page registers for a service worker, allowing us to do something about that second load. Registration is simple. It's just a line of JavaScript like this. Give it the location of your script. You can also scope it to an area of your origin, and that's useful if you have a single origin with many apps on it, like Google does with Calendar and things like that. The default scope is the whole origin, which we'll use here. It returns a promise, so you get to find out if it worked or not. You can only register for a service worker on pages served over HTTPS. The service worker is so powerful that it would be a disaster if that falls into the hands of a man in the middle. GitHub pages serve over HTTPS, so they're a good place to put demo stuff. And localhost is exempt for development. As for Worker.js, we're just going to put a console log in there. We're also going to listen for the install event. This fires when the browser sees this service worker for the first time. So let's see that in action. First, I'm going to go to Service Worker internals, which is where our debugging stuff is living at the moment. As you can see, there's nothing there. And then I'm going to open the train site, a dev version of it, and open DevTools. And as you can see in the bottom corner there, our service worker is successfully registered. If we go over into a Service Worker internals, there it is. There's our console logs. But even better, we can launch a DevTools window where we can see the same console logs, but we can also set breakpoints and run stuff on the console, etc. If we fast forward time a bit, the service worker terminates. That's not a bug. It's just not needed at the moment, so it closes to conserve memory. And congratulations. At that point, you are now wielding the power of the service worker. But what did that actually get us? Nothing. But wait. Oh my God. It's actually a good thing that it does nothing. They unapologetically made it good. Compare it to app cache. If you give an HTML page a manifest, and that manifest only contains the words cache manifest, which is required to make it valid, yeah, sure, I'd expect my page to go from this to this, said no one ever in the world. So we didn't want to do that. Service Worker doesn't do anything unless you tell it to do something. App cache broke a lot of eggs, and it failed to make an omelet. But it's made of the right ingredients. It's got routing, fetching, caching, updating, and version control. But because it's app cache, in order to get to them, you must first traverse the piles of implicit behavior, which are, of course, guarded by the army of robot wasps. If you've used app cache before, you'll know what I mean. So we got rid of all of that. We separated them out so they could be used however you want without getting stung. This is the extensible web. Don't let the platform give you a fish. Ask for the fishing rod and how to use it. But take the fish as well. Right? We need both high and low-level APIs in the platform. First up, routing, putting you in control of requests. The service worker is event-driven. We've already seen install, but there's also fetch. This fires for any navigation to your scope, but also for any sub-resource from that page. In Service Worker internals, I'm going to start up the service worker, and we'll inspect it. And then I'm going to navigate to our train site. And you can see, as soon as we navigate, we hit this breakpoint in the fetch event, and that's for our root page. If we move on from there, we'll get one for the CSS. We skip from there, we'll get the logo, the JavaScript. No, we rendered before JavaScript because we care about performance. And then we get one for the API call to Flickr. Even though this request is to another origin, we will get an event for it. And then we get all the image requests coming in. But hey, the cool bit is, this is an event. And like other events such as click, touch start, and key down, you can prevent the default and do something else. You can respond with something else. Responses can be created manually. And that's what I'm doing here, just new response, give it some text. And if we do that, the page goes from this to this. Yeah. But the interesting thing here is we delivered that without going to the network at all, making it the first offline demo of the talk, only almost halfway through. But we can do better than that. When the browser discovers the service worker for the first time, we'll send it off to the network. You get it to make a load of requests. And when they're done, we'll get a lot of responses. And that might be fast, it might be slow. The network is unpredictable, we don't care. We're not disrupting the user, they already have the page open. If our responses come back, we'll put them in the cache. This pre-caching method is what a native equivalent would do with its initial install package. But we get to do it in the background without disrupting the user. For our train site, this is things like the root page template, CSS, JavaScript, and design images, all the static stuff. And then in future, when we get a request for one of those things, we'll just get it from the cache, send it back to the page. The uncertainty of the network is no longer our problem. And this is really simple, thanks to the caching API, which gives you full programmatic control of the cache. In terms of our train site, in the install event from earlier, we get this event.waitUntil, and we can pass a promise into there that extends the installation process, or you can use it to indicate success and failure as well. So in here, we're going to create a cache, give it a name, that gives us a cache object, and then we're going to add stuff to it, all of our static assets. This is an atomic operation. If any of these fail, the whole operation fails. and this ServiceWorker won't control pages. So if install succeeds, we know we have these things in the cache. There are dependencies. The cache itself isn't in Canary yet, but there's a polyfill backed by IDB. The proper implementation will land in a few weeks. So how do we use these cached items? Well, over in the fetch event, event.respondWith, caches.match, and pass in the request. And this will go to the cache, and it will find a response that matches that request. Matching is done by method, URL, and vary headers, similar to the browser cache. If there's no match, you'll get null back. But promises let us recover from that. So if we get null back, we can send off something else. What should we do instead? We could send another thing from the cache, a fallback entry. But what if we want to try the network? To do this, we need to be able to make a request using JavaScript. In 1999, Microsoft engineers were designing a new exciting API. But what should they call it? It contained some abbreviations, some initialisms. They couldn't decide if they should be all caps, like in a HTML, or just the first letter, like getElementById. So they did both. An XML HTTP request was born. Other than that, the name is perfect. XML, because it only deals with XML, except it doesn't. HTTP, because it's restricted to HTTP, except it isn't. And request, because you get a request object back, except you don't. We tried to modernize it a bit so it makes more sense, but it's still pretty bad. Fetching from JSON is verbose and weird. We've been patching this API up for 15 years. I do not want to be using this API when it is old enough to drink. Thankfully, the fetch spec by Arno van Kesteren of Mozilla, it gives us lower-level control over requests and responses. We've already seen some of it, the request object and the response object. Lower-level APIs are usually more difficult to use than higher-level ones, but XHR is so bad, that is not true here. The equivalent to this in fetch URL, gives you a promise, parse it how you want, gives you a promise, done. This is a forward-thinking API too. ES6 arrow functions make it neater. ES7 async functions can make it a one-liner if you want. So to answer the question, how do we send this request to the network? Fetch. So where does this get us? What improvements does this give us? Well, 3, 2, 1, go. We render almost instantly. We get content after a couple of seconds. We're still going to the network for that content, but our JavaScript arrived so much quicker, it was able to start that request so much sooner. Still a sad story with the images, though. Let's fix that. When there's a request for a Flickr image, it'll go to the ServiceWorker, like everything does. If we have it in the cache, we'll return it from the cache. Otherwise, off we go to the network. But when we get a response back, we'll send it to 2 places. We'll send it to the cache and the page, so it's there for next time. We're doing this for Flickr images, but this pattern is also good for things like avatars, things you want to cache as you go along. To do this, we're going to special case URLs that end in staticflickr.com. That's where the images come from. In that case, we'll take the request, try and get it from the cache, and return it if we find something. Otherwise, fetch it from the network, add it to our cache, send it back to the browser. We need to be careful with this pattern, because we're adding to the cache for every image request. We'll need to kind of garden it at some point. We'll pick that up later, but for now, how does that improve things? 3, 2, 1, go. We render quickly, content comes through pretty quickly, but this time we have images. All of the images that we've seen already, but not this one at the top, that's new. That comes through in 11 seconds. And that's pretty good, but we're still dependent on the network for that initial API call that tells us which images to display. Let's fix that. So this one's a little bit different. The page does a fetch for the API, which goes via the ServiceWorker, as everything does. But at the same time, it also goes straight to the cache, because pages can access the cache too. And if it finds a response, it will take it and it will render with it. And then that will trigger all the requests for the old images that we've seen already, which are also in the cache. Meanwhile, the ServiceWorker goes off to the network, off to Flickr's servers, and gets data back. And we do what we did with the images. We send it both to the cache and the page. This is also a good point for us to clean up the cache. With this pattern, the page makes 2 requests, and it renders content twice. Once from the cache, another from the network. That means we get to render quickly with old content, but provide up-to-date content when we find it. The best native apps do this. Very few, but the best ones do. So here's where we're at now. We're special casing static Flickr. We also want to special case api.flickr.com. In that case, we'll do this. And I'm not going to go through this line by line. This is fetching data, caching it, returning it to the browser. This sort of gnarly bit in the middle is where I'm parsing the data from Flickr, looking at the image URLs in there, and removing ones from the cache that we don't need anymore. This is a little bit gnarly, even with promises. ES7 async functions make it a lot neater. But that's the service worker sorted. But this pattern requires the page to make 2 requests. So over on the page side, we set up 2 requests, one to the cache and one to the network. If the network response comes in after the cache, we'll update. We show an error if both the network and the cache fail to provide data. If the cache succeeds but the network fails, we fail silently. That's a good offline case. That was probably too much code to show on slides, I think, even at JSConf. But my point is, we're expressing relatively complex, custom async behaviors in relatively small amounts of code, even using the low-level primitives. And the effect of that? Let's remind ourselves where we started. First visit takes quite a long time to get to first render, just over a second. Then content comes in after over 5 seconds. And then we're waiting forever for the images. With ServiceWorker and the code we've written to manage the network and the caching, 3, 2, 1, go. And we have what looks like a complete view rendered really quickly. New data comes in after a couple of seconds, doesn't disrupt the user. If they scroll up, they see it, and we get the new image. We shaved a second off first render, over 36 seconds for what looks like a complete view. With ServiceWorker, you can get content on the screen in a fraction of a second. Whether you have a fast connection, a slow connection, or no connection, it doesn't matter. This is what catches us up with the startup performance of native. And it gives us the foundation for these other features, such as push notifications and background sync. First up, push, something I depend on for many apps. Before we look at the code, I'm going to give a live demo a go, which is, we'll see how this goes. So, Remy, could you help me with this? Come on. So I need the projector working. I don't know. Thank you. Ooh. So, Remy, you are going to send a chat in there, but not until we have something on the screen. How's it going, by the way?
Fine.
Yeah, it's pretty good.
Yeah.
I know.
It's a one-way conversation.
Enjoying the morning so far? Was breakfast good?
Yes.
Yeah? Oh, that's pretty good.
How's your breakfast?
I didn't have breakfast. I was afraid I might throw it up.
Yeah,
It's the nerves, yeah. Oh, here we go. OK, so this is a simple chat app. This is running in an internal build of Chromium, but based on actual spec work. So, Remy, if you could just type in any message in there. Oh, that's nice. Thank you, whoever tweeted that. That's good. Oh, that's lovely. No one tweet anything rude right now. So, did you send a message there?
Yeah.
That's good. How's the Wi-Fi holding up? I guess it's... let's refresh that. Go again. Oh, that's a disaster, isn't it? OK, I'm going to refresh this one as well. Go again. If not, we'll just abandon it. It's live demos, right?
Did you say don't swear?
Yes, but it's great because it's not going to display. So, well, I'm getting tweets, which is a good sign. Oh, this worked like 5 minutes ago. No, we might just have to abandon it. I'm going to drop onto roaming and see if that helps. Restart Chrome. Oh, that's a good idea. That normally fixes everything. We're using Firefox here to send the messages, so I could always blame that. Go on, we'll give it one more go. If not, we'll just abandon it. Yes! Oh, thank you, Remy. You're so... OK. Whew. No, stay. But we've seen that happen before, right? This is nothing new. But what I'm going to do now is I'm going to close Chromium completely. And now there's not yet. Now there's nothing. The browser's not open at all. I have no recent apps on. So, Remy, would you care to send another message? Now, what we're getting here, this is a push notification using open web features. This, a completely native notification. The browser was closed, but it started up the service worker in the background, and we got a push notification. And because it's all using native notifications, it has also appeared on my watch as well, just using the open web. Remy Sharp's birthday as well. Can we switch back over to the laptop? Is that possible? How do we? Where are the connectors for that? Birthday, dear Remy. Brilliant. So, right, I'm hideously running over now. The way we coded that, and this is just a standard, from your page, you register for push messaging. We'll give you the details, like the ID and the endpoint where to send messages. But when that actually, when that's called, you'll get an event in the service worker. You get to do what you want at this point. You look at the data, update caches, show a notification. And when the notification is clicked, once again, you get to do what you want. In our case, you could navigate to a page or refocus an existing tab. Background sync is very similar. I won't go through it, but you don't need a server operation for that. You're just saying, sometime later, can you fire an event in the service worker for me to do something I was unable to do earlier, or update on an interval. These things require user permission, of course. They'll be told about this. I have 10 minutes? Oh. I'm going to tell you about how to code, push, and sync, then. OK. How did that demo work, Jake? Well, I'll tell you. From the page, you call navigator.serviceworker.ready, and that gives you the registration details of the service worker, where you can look at the state of the installation process. On that registration, we call push.register. That gives you the details, and you post those to your server. You'll kind of associate that with the current user, because that will give you the endpoint information where you're going to send data. For Chrome, that's going to be GCM, Google Cloud Messaging, but every browser is allowed to use their own. You'll need to have an account set up with the different push messaging providers, but the data that you'll send to these things will be exactly the same. You'll just have to know where you're sending it, which will just be a URL. When the user receives a push message on a device, it spins up the service worker in the background. You get a push event, and you just have a look. What kind of data is it? I'm going to react to that. In our case, I'm going to do event.waitUntil. I'm going to update the train caches. This is a pet hate of mine. Oh, afterwards, we're just going to show a notification. This is something that native, even the really best native apps, they get this wrong. That quite often I'll get a tweet, and I won't notice it when it just arrives. But on the underground, I'll see the notification, and I'll click it, and I get nothing, because they haven't cached that data offline. We can do the right thing here, update the caches before we show the notification. You get an event when the user clicks the notification, and you do what you want, usually navigating to the page. We also give you a way to enumerate service worker clients, which are the pages that are within your scope. So you can look at them, see if they're focused, see if they're hidden. So you can know, oh, hang on, there's already a window that has focus, so I don't need to show a notification, or I don't need to navigate anywhere. It's, I can determine that stuff ahead of time. What about background sync? This lets you wake up the service worker at some vague point in the future to do whatever you want. So this is a bit similar to push. It's actually quite a lot simpler. So if you try and send an email, but the user has no connection, or the server's down, so it fails, you can save it somewhere, probably IDB or the Cache API. And then you register for a sync event. You just give it an ID, and that will trigger a permission dialog. That returns a promise. And then sometime later, when the user has good connectivity, you'll get a sync event. You get to do what you want, which would be, if the ID's empty inbox, we'll get the outbox and try and send all of those emails. Event.waitUntil, in this pattern, it works similar to the install event. If you pass it a rejected promise, it will go, oh, well, that didn't work. It will reschedule the sync event. So in that case, if we fail to send one of these emails, it will be rescheduled for later. So this is registering for a single sync event, like do this when the user has a connection. But you can ask for ones on an interval as well, so we would use that for like updating train data in the background. The interval you specify is a minimum. When syncs happen will be determined heuristically by the browser. It'll take things into how often does the user use the app. If you've registered for a sync once a day, and we know that the user looks at your app like about 9 o'clock in the morning, we can schedule the sync for 10 to 9. We can do clever stuff there, and coalesce it with other sync events to preserve battery life. With ServiceWorker, we gain a lot of the features that make native superior, but we retain the bits that keep the web superior. The instant on, no install required. It's an open platform. Chrome is going to start shipping this stuff this year. It's already in Canary. It'll go to stable this year or early next year. Firefox are actively developing it. Microsoft are investigating it. We haven't heard anything from Apple, but that's not unusual at this stage. But it's designed to be an enhancement. I mean, no browser is going to have it there on the first visit to your site, so you have to prepare for that. And as long as you use basic object detection, you can give this benefit to the browsers that support it, which is a lot of users in Chrome's case. ServiceWorker doesn't make stuff work offline. It doesn't turn push messages into cache updates and notifications. It gives you nothing for free, but it treats you like an adult. It gives you the moving parts and says, do what you want. Use it to make things faster, make things work offline, create new features, transcode a video format using streams, turn it into something the browser supports. Build a client-side wiki, we've seen that already. Do what you want. Do it in a way that's unique to your app, the way that gives the best user experience. I am heavily biased, but I think this changes the scope of what the web is capable of more than any feature since XHR. Let's build some cool stuff with it. Thank you very much.